x plus 1, if it is written there, two functions are with the division sign, two expression x divided by x plus 1, then how to do that? Divide dx of this expression. So like product rule, we needed to apply one formula. If we consider the top one as a u, if two expression given as a division in terms of x, then we needed to apply the formula for that equals v du by dx minus u dv by dx divided by v square. This is our formula. We are going to apply that formula here. So we needed to consider top one as a u, then consider below one as a v. U written here, say u equals to x and v is x plus 1. Just apply the formula. We know du by dx equals to 1 and dv by dx is as well 1. So now just apply the formula here. The formula on the top, it is written v du by dx. So v du by dx, that 2 we needed to multiply, which is 1 into x plus 1. Then there is a minus sign from the formula, minus u dv by dx. Accordingly, u dv by dx, so we needed to multiply that 2, which is x into 1, and the below one is v square. It is written the v square, so v as x plus 1, so x plus 1 whole square, which gives us, we can simplify more, x plus 1 minus x divided by x plus 1 whole square. Now we can cut out this 2x, so the remaining part 1 divided by x plus 1 whole square is answer of this question. So this is the quotient rule. If two expression of x given as a division sign. Let's consider another example. Say it is written there x square divided by twice x minus 1. Say another example. So same, we need to consider u as x square, then v, let me consider twice x minus 1, then du by dx, if I differentiate on the left side, it gives us 2x, and dv by dx, which gives us 2. We learned it, the general differentiation. If you don't understand how we are getting this one, so you need to see my previous videos, previous tutorials to get understand, say tutorial 1, tutorial 2, then you get the idea how why we are doing this. So d by dx of the whole expression. Now applying the formula, first one is a v du by dx, so we need to multiply this two expression, which is 2x into 2x minus 1. Then according to the formula there is a minus sign. Then let me write the another part, which is u dv by dx, u dv by dx. So 2x square you can write, and the denominator, which is 2x minus 1, we need to write it with a square. We also can write by simplified form by breaking down it, 2x into 2x, which gives us 4x square. Then 2x into 1 is minus 2x, then minus 2x square, then the remaining part on the below, x twice x minus 1 whole square. From the top we can subtract 4x square minus 2x square, which gives us 2x square, then again minus 2x. So from the below we can write it 2x minus 1 whole square. So see, from the top we can take 2x common, then the remaining part is x minus 1, and the bottom it is written 2x minus 1 whole square. So we can leave our answer here. That is our answer. So no further simplification is needed for doing that. So let's see another example, last example, row example, which you can write x minus 1 whole square divided by the expression is given there 3x plus 1 whole cube. You might think that why we are not using the product rule by writing this application of the indices, you also got the same answer, 3x plus 1 to the power minus 3. Now we can apply here the product rule to get the answer, but I would suggest you better to, if the two expressions are given as a division, better to use the product, quotient rule, not to use the product rule, because you needed to apply this one in further calculation, say equation of tangent, equation of normal, or finding the stationary point. Then it makes trouble, simplification makes trouble. So better to use, if written here the quotient, so in the division form, better to use the division form. So according the way we did the previous one, let you consider x equals to x minus 1, b equals to 3x plus 1 to the power 3. So we got from here du by dx, like the thing 2 into x minus 1, then from power 1 if we subtract it would be 1. So next one, dv by dx, we can write it 3 into 3x plus 1 square into, inside the bracket if we differentiate we got from here another 3. So finally you can write it, this is the 9 into 3x plus 1 whole square. So that is our expression. Now let me apply the formula or total thing from there. So the formula is u dv by dx, quotient rule formula, v du by dx, v du by dx. So this is our v, we needed to multiply these two first, so which is 2 into x minus 1, then 3x plus 1 to the power 3, inside the, then minus, we need to multiply this two, which is 9 into 3x plus 1 whole square, and the other part we need to write x minus 1 whole square, and the as a denominator we are going to write here, what you can write, denominator we can write its denominator 3x plus 1, so it would be 3x plus 1 to the power square of that, 3 square is 6. So I'm not going to simplify it, we can simplify it more from here, but differentiation is done, we can leave our answer here because we are not using that part in another purpose, so we can leave our answer here. So let's see if the statement sum of the quotient rule given there, how it looks like. Say one question I prepared for you, find the gradient of the curve if it is written like this at the point x equals to 2. What is the gradient? So same procedure we can apply here. We, for gradient, we needed to find out first dy by dx, dy by dx. Let me write the expression. We can write the expression like this. First one is v dy by dx of u, which is x plus 1 square, then minus sign, x plus 1 square, u dv by dx of v, which is x minus 3 to the power 3, and the below we need to write x minus 3 to the power 6. So now use differentiation, which is x minus 3 whole cube. From the differentiation part we would get from here 2 into x plus 1, then minus x plus 1 whole square, and which is 3 into x minus 3 whole square, and outside of the bracket x minus 3, if we differentiate we got the one, we are not writing that, and the below one is x minus 3 to the power 6. That is our total expression of this. So they ask at a particular point where the x equals to 2, asking the gradient, so we can write here the gradient now by putting the value gradient equals to, let me put the value x equals to 2 on the expression, which gives us 2 minus 3 whole cube. In front of 2 we can put it first, then 2 plus 1, then minus 2 plus 1 square, in front of it let me write 3, then 2 minus 3 whole square divided by 2 minus 3 to the power 6. If I made any mistake, please correct me by writing in the comments below, because I am doing it directly without calculator, so there is a good chance to make mistake, but I would suggest you to use calculator. So this is 2 into minus 1 into 3 from the first expression. Then the second one we got from here, minus 3 into 3 square is 9 into minus 1 whole square is, which is 1, and from the below minus 1 to the power 6, which gives us 1. So finally we got from here minus 3 to the 6, and on the right side, which is 3 9 the 27 minus 27, so 27 minus 6, which is minus 33. This is our answer. This is the value of the gradient at the point x equals to 2 of that expression. Another question I wrote for you, it's written here, find the x coordinate of the point on the curve where the gradient is 0. This is written here, gradient is 0. So let me try this question, how to do that. Same, we need to consider if gradient is 0, dy by dx first. Dy by dx equals to 0, because dy by dx is the gradient expression. We need to consider 0, then we can find out the value of the x from here. So apply the formula. Let me apply the formula. Dy by dx. First one, we need to write v x plus 2 square, then divide dx of, by writing separately as a uv, or you also can write directly this one, minus twice x minus 5 cube divide dx of x plus 2 whole square. See the formula, this one I consider as a u, this one I consider as a v, and our formula is v du by dx minus u dv by dx divided by v square. We apply this formula here. So as a v square, we can write it x plus 2 to the power 4. So that is our expression. We can consider that expression directly 0, because the gradient, it is written that gradient is 0. Now we can find out the answer from here. So denominator, if I consider this is the expression as equation, so the denominator goes to the right side as a multiplication, then it becomes 0. Only the top part, I mean numerator part is remaining here. Let you write the whole thing, which is x plus 2 whole square, another part 3 into 2x minus 5 to the power square into 2, because if you needed to differentiate inside the bracket, then we get from here 2 minus another part twice x minus 5 whole cube, and divide dx of part 2 into x plus 2, then consider 0, because this goes to the right side as a multiplication. We got from here 0, something multiplied with 0 becomes 0. Now from there we can take common, some of the part we can take common. Let me take the common. First we can take common 2 as a number. See, 2 is a common number. Let me take 2 common first. This is the 2. Then you can take x plus 2, because x plus 2 is written here. Then another part you can take common, say twice x minus 5 whole square you can take common. Then write the rest of the part from the first. It is remaining 3 into x plus 2, because rest of the part I took common from here. This is the first expression, and the second expression here, let you write this by writing the minus sign. Minus 2 gone as a common, x plus 2 gone, so remaining part is twice x minus 5 only. So let you write twice x minus 5, because I took 2x minus 5 whole square as a common, so the remaining part is twice x minus 5. Now simplified it, 2 into x plus 2, second part is twice x minus 5 whole square, and the third part you can write here 3x plus 3 to the 6 minus 2x plus 5 equals to 0. So one more line we can write here, which is 2 into x plus 2. Then another part is twice x minus 5 whole square. Then the last part is x plus 5 plus 6 is 11 equals to 0. So see, now it's easy to find out the answer the way we did the previous equation. Three factors are there. This is one factor, second factor, third factor. Consider individually 0, which you can write x plus 2 equals to 0. Then twice x minus 5 whole square equals to 0, and another part x plus 11 equals to 0. So you might think that what 2 goes, because 2 is a number, 0 divided by 2 number, it cancel out. So x we got minus 2, and from the second expression we got x equals to twice x minus 5 equals to 0. So x we got from here 5 over 2. We also can write it as a 2.5, and the last expression we got from here minus 11. So this 3 is the answer of that expression. This first answer, second answer, and one negative answer, which is x equals to minus 11. Likewise, before I prepared one worksheet for you, which is this according to the quotient rule. So that already have been uploaded in the description below of this video. You can download it with a single click for your practice, and next tutorial will go for the tangent and normal from here.